You've just finished watching an epic movie on your favorite streaming platform, and before you can just grab the popcorn crumbs, bam, you're hit with a list of recommendations that seem like they were just made for you. Ever wondered how it knows your taste so well? What about those self-driving cars? Have you seen them before? I guess you have. They're gliding down the streets like they belong to some kind of sci-fi blockbusters. What's the secret behind them driving themselves? And when it comes to social media, you uploaded photos for last weekend's barbecue, and in an instant, it tags all your friends like it's been spying on your life. Spooky, right? Well, I'm here to tell you, it's not magic. The truth behind all of this is a couple of words: artificial intelligence. But don't get too excited and comfortable thinking it's all hocus pocus. We're about to dig into the technology that makes all this possible. So get ready, because it's time to uncover the real story behind these everyday marvels. Let's start by defining things. AI first. Artificial intelligence. Artificial intelligence is the science of enabling computers to mimic human intelligence. This is achieved by emulating human cognitive abilities such as perception, reasoning, planning, and decision-making. Beautiful. But we often keep hearing about two more terminologies that are often associated with artificial intelligence. These are ML and DL, machine learning and deep learning. Caught your attention. Machine learning. Oh, what's that? Machine learning is a branch of AI that allows computers to learn from data by recognizing patterns and then make decisions without the need for any kind of programming inputs. ML has become the most influential method in AI today, which is why it's often used interchangeably with AI in modern discussion. Deep learning, on the other hand, takes it a step further. Deep learning is a subset of machine learning. It uses something very interesting called neural networks. Oh, what's that? Neural networks is loosely inspired by human brain. It analyzes massive amounts of data, especially unstructured data, such as images and audio, for example. Think of neural networks like an assembly line, for example. Each layer of neurons processes input and passes it to the next layer. The more layers, the deeper the model, and this is where the name deep learning comes from. So while AI is the overarching concept of smart machines, machine learning is one way to achieve that, while deep learning is the powerhouse driving the most advanced applications today. So what are the different flavors of AI? Well, the most famous two are traditional AI and generative AI. What are they, and what do they do, and what do they offer? This is what we need to talk about next. Traditional AI is your ultimate rule follower, where computers operated using rule-based systems, or in other words, symbolic AI. In this approach, the AI followed some kind of explicit if-then logic, set of instructions predetermined by human programmers. Yes, this is programming. As time passed, this traditional AI evolved into something even more, something smarter. Though not independent yet, but they started calling it the expert system. This is actually a branch of the traditional AI, but designed to mimic the decision-making abilities of the human experts. This system was powered by a knowledge base and applied some kind of inference rules. Watch the word, inference rules, to make this. We're going to use that word often. Inference rules were, determined there to make some kind of decisions. Imagine having a doctor on a call who consults a giant medical book every time he needs to diagnose a patient. Well, it's good to recap on your knowledge as a doctor, but this is not very efficient. You will give the medicine, but hey, these systems could provide smarter answers, but only within a narrow set of boundaries, or some kind of pre-fed knowledge. If you don't have that knowledge, it's not going to function. They were not learning. They were just great at applying stored rules. Let's talk about the traditional AI process, which starts when a user provides some kind of input, like data or questions, for example, that is being passed to an inference engine. Oh, what's that? Inference engine? Glad you asked. The inference engine is a software component which applies the logical rules to a knowledge base. This goes through a bunch of different phases like matching the rules, selecting the rules, and executing those rules. So in the second step, the inference engine is going to need to consult with that knowledge base that has all the rules and the data stored in there. Then in the third step, still the inference engine is there. It will try to interpret what has been entered by the user and match it with the rules retrieved from the knowledge base through a step called processing flow. This step does not necessarily happen from the first interaction between the two, between the inference engine and the knowledge base. It can be a repetitive step. There will be some kind of real-time interaction between the inference engine and the knowledge base, which is another word and iterative cycle that involves always consulting the knowledge base to ensure that the inference engine keeps improving on its intermediate results until it lands on an optimum solution. And then finally, the engine is going to deliver that final, well-analyzed result based on its logical analysis. But before moving to that superior version of AI, let's first focus on the applications of traditional AI. You can apply traditional AI in a bunch of different things, and it's actually very commonly used. First of all, the expert systems. The expert systems were used in fields like healthcare for medical diagnosis and financial analysis. Another example is the rule-based system. The systems that follow the if-then rule, as I mentioned before, often used in process automation and customer support, the early chatbot model, if you remember that. Then we have the banking sector, fraud detection. Yeah, the traditional AI use the predefined rules and patterns to identify fraudulent activities in banking transactions, often detecting the anomalies in the credit card usage. Well, we still have that till now. The future required AI to adapt and learn on its own. This was the stepping stone to today's generative AI. Generative AI, also known as Gen AI, does not just follow predefined instructions, it creates entirely new content. Gen AI actually uses different kind of models. One of them is called GAN, the Generative Adversarial Networks. To do what? To produce new data, be it text, images, or music. This breakthrough allows AI to move from following instructions to inventing novels, outputs, and revolutionizing creativity and innovation in the AI domain and the AI world. The secret to generative AI's creativity lies in self-supervised learning and deep learning. Okay, instead of just relying on labeled data, the AI trains itself on vast amounts of unlabeled data to learn patterns and structures and relationships within the data itself. It's like reading a million books and learning how to write on your own, absorbing massive amounts of information and generating new content based on those patterns. This is so mind-blowing. Generative AI can be used in many sectors. It can be applied anywhere, and it has lots and lots of benefits. For example, it can generate text, images, music, videos, automate content for businesses or for marketing or for even media. Image enhancement, for example, which can be used to improve image resolution and quality and restore damaged images for media or for even security reasons. And then in the gaming domain, it can create game worlds and characters and levels, enriching the virtual experiment and the virtual environments. Personalization, on the other hand, which can, be represented in chatbots and virtual assistants. I can say generative AI accelerates innovation and automation, transforming industries by enhancing creativity, efficiency, and personalization. Summary time. Artificial intelligence enables machines to mimic human intelligence, with machine learning allowing machines to learn from data, and deep learning using neural networks to process complex, unstructured data. Traditional AI uses strict if-then rules for decision-making, and it's often used in process automation and chatbots, whereas generative AI creates new content like text or images by learning from large data sets using self-supervised and deep learning, driving innovation. GANs train generative AI models by having a generator create fake data and discriminator evaluate it, leading to higher realistic content throughout the competition. I hope that this was an informative video. I'd like to thank you for viewing.